Continuing on, this is x minus 1 over x into x minus 3, so that is a over x plus b over x minus 3. We clear the fractions, we always do. X minus 1 equal x minus 3 plus bx. So again, we choose our trick, and our trick states, well, what x values are you not allowed to have? You can't have x equals 0. Let x equal 0. 0 in there will make that a negative 1 equal. A 0 in there will make that a times negative 3. And a 0 in there will make that disappear. So a is 1/3. And x cannot be 3. Let x equal 3. A 3 minus 1 is 2. A 3 in there will make that a 0. And a 3 in there will make that 3b. So b is 2/3. Replace this by 2/3, replace this by 1/3, and there's your answer. You could write it again if you wish. This is 3x minus 1 over x into x squared plus 2x minus 3, 3x minus 1 over x into x plus 3 into x minus 1. So 3x minus 1 over x into x plus 3 into x minus 1 is going to have 3 fractions. Linear, the denominator is linear, the top is 1 power less. So I'll find a, b, and c. Clear the fractions. No need to multiply those. Things balance out very nicely. There. Now, what values am I not allowed to have? I can't have x equals 0. Let x equal 0. That will mean negative 1 equal a. A 0 there will make that a 3. A 0 there will make that a negative 1. A 0 there, that will disappear, and a 0 there, that will be 0. So that means a is 1/3. Let x be the second. The x cannot be negative 3. Let x equal negative 3. Negative 3 times 3, negative 9, negative 10 equal. A negative 3 there, that's 0. A negative 3 there and there, that will be b times negative 3. Negative 3 minus 1 is negative 4. A negative 3 there will make that a 0. That indicates that that's 12. b is negative 10 over 12, or negative 5 over 6. And if you go for the third value, you can't have x equal 1. Let x equal 1. 3 minus 1 is 2. A 1 in there, that's a 0. A 1 in there, that's a 0. A 1 in these x's, c times 1, and 1 plus 3 is 4. c is 1/2. And that's how complex this is. This trick is not in our book, but it's a very nice trick. It works, let's say, 95% of the time. And let me move this down, move a bit more space on this one. And how about this problem? Well, this I can write as x minus 2 plus x minus 2 squared. That's linear. Since this can be written as the product of linear factors, that's b. Get traditional, get rid of the parentheses. X plus 1 equal a into x minus 2 plus b. So that's the equation. Here, x cannot be 2, so let x equal 2. What would happen? 2 plus 1 is 3. A 2 in there will make that a 0 plus b, so b is 3. Then, well, that's all there is. The catch, you could choose x to be anything you like. Let's say x equals 0. Put a 0 there. 0 plus 1 is 1. A 0 in there, that will be a times 0 minus 2 is negative 2. And b I already found. So you have to solve that equation. Negative 2a equal, move that over, that's negative 2, a is 1. And there's my answer. So this trick works sometimes with just the zeros, but sometimes you have to find a few more values. How about this problem? This is this is x minus 2, and this is x minus 1 squared. So x minus 2, x minus 1, and x minus 1 squared is the least amount of work I could do. Linear, linear, the product of linear factors, get rid of the parentheses. So hopefully you're getting comfy with this. This is missing an x minus 2 and an x minus 1, and this is missing an x minus 2. And what are the restrictions? X cannot be 2, let x equal 2. Add 2 in there, 2 plus 4 is 6. Add 2 in there will make that 2 minus 1, which is 1 squared, that's 1. Add 2 in there will make that a 0, add 2 in there will make that a 0, a is 6. Lovely. There it is. The other value, I can't have x equal 1, let x equal 1. I'll get 1 plus 4, which is 5. A 1 in there, that's a 0. A 1 in there, that's a 0. A 1 in there, that is c. 1 minus 2 is negative 1, so c is negative 5. So this trick is really quick and efficient. Now I run out of terms to pick any value. Let x equal any number you want. You could choose anything other than 2 or 1. I could choose 0, I could choose 5, I could choose 10, whatever you want. Put a 0 right there for x. That would be a 4 equal. Now remember, I know that a is 6, and I know that b is a negative 5. Having known those, this makes it very simple. That's a 6 times. If I put a 0 there, that's negative 1 squared, which is 1, minus 5. If I put a 0 there, that's a negative 2, plus c times, and if I put a 0 there, that's negative 2. So you just have to solve. Not that bad. 6 plus 10 minus 2c, that's 16. If I subtract 16 from both sides, I get negative 12 equal negative 2c. That means c is 6. It beats solving systems of 3 by 3. Very efficient and useful. The next problem up, I factor that. That is x squared into x plus 2 plus 3 into x plus 2. That is x plus 2 into x squared plus 3. So this is going to be a over x plus 2 plus, since that's irreducible, that's bx plus c. So I'm going to clear the fractions and say x plus 3 equals a. This is missing an x squared plus 3, and this is missing an x plus 2. Now, I could use the book's method on this, or I could say, you know what values am I not allowed to have? I'm not allowed to have a negative 2. Let x equal negative 2. At least I could find one of these unknowns. Negative 2 in there, that will make that a 1. A negative 2 in there will make that 4 plus 3, that's 7. A negative 2 in there will make that a 0. So a is 1 over 7. The fact that I know that this is 1 over 7, that's going to save me some time. Now, I ran out of numbers. Well, let x equal, let's say 0. 3 equals 1 over 7. A 0 in there will make that a 3. And a 0 there, that's gone. That will be c. And a 0 there, that will be a 2. So, 21 equals 3 plus 14c. 19 equal 14c, c or 18, right? Subtract 3. 9 over 7. A bit more work than we like, and I could choose x to be, say, 1. And remember, now I know that this is 9 over 7. If I put 1, that's a 4. A 1 in there. That's 1 over 7 times 1 plus 3 is 4. A 1 in there, that will make that a b, plus 9 over 7. And a 1 in there will make that a 3. Again, a bit of a mess to solve. 4 equal 4 over 7 plus 3b plus 27 over 27 over 7. So 28 equal 4 plus 21b plus 27. This is 31. 28 minus 31 is negative 3. So b is negative 1 over 7. So again, sometimes the numbers are that messy. So I could say that is 1 over 7 over x plus 2 plus a negative 1 over 7x plus 9 over 7 over x squared plus 3. They might factor a 1 out of 7 out of all of those. You don't have to. And there it is. So sometimes you have to do this. If I can zero out a lot of those, maybe I'll use the books method and proceed. And this is the last example, and I picked, as messy of things as I could choose. So this is 3 over x into x plus 2 squared. That is a over x plus 2 plus x plus 2 squared. That is b, and since that can be written as a linear factors, that is c. And how does that work? I clear the fractions. A into x plus 2 squared plus bx times x plus 2 plus cx. Well, I can make that a 0 by letting x equal 0, 3 equal a 0 in there, that's a times 4, a 0 in there, that's a 0, and a 0 in there, that's a 0. A is 3/4. Let x equal negative 2. I'll get 3 to equal, that's a 0, that's a 0, negative 2c, so c is negative 3 halves. Now I'll substitute the negative 3 halves there, I'll substitute the 3/4 there, and I can choose 0 or negative 2. Let x equal 1. I'll get 3 equal 3/4, a 1 in there, 1 plus 2 is 3, squared, that's a 9, minus 3 halves, a 1 in there, that will make that a 3, plus c. So this is 3 equal 27 over 4 minus 9 over 2 plus c. The LCD is a 4. 12 equal 27 minus multiply by 2 plus 4c. 12 equal 18 to 27, that's a 9, if I'm not mistaken. So that is 3 equal 4c, so c equal 4/3. And there it is. And that's pretty much it for this section.